All right, folks, welcome to Yak Math videos for your calculus exam number 3 in spring 2018 review video for part 2. Today we are brought to you by our in-house sponsors of Hammer Gel, Cliff Shots, and The Cup gluten-free cupcakes, of course. Yum yum, go get you some. All right, folks, tomorrow you're going to have 12 integrals total, 6 indefinite, 6 definite, I believe. You're going to have some U substitution in there, and then 3 other questions, 15 total today at 19. Got off to a pretty good start. Folks, on 21, this is an indefinite integral, okay? You don't need U substitution at all. You're going to divide all those terms by 2 and then subtract x to the 1/2 power from each, folks. All right, that's how it simplifies, and then take the antiderivative. There we go. Again, check this. If I made a boo-boo, let me know later. All right, folks, just distribute on 23 and then take the antiderivative. That is no big deal. On 24, that's the time to use U substitution. Technically, you could do 4x squared plus 3, raise that to the 3rd power, but that would be a mess. If you let u be 4x squared plus 3, then du is 8x dx, but I just need x dx somewhere, so if I divide by 8, 1/8 du is that x dx I need to substitute in for. So then I can rewrite it as 1/8 the integral u to the 3rd there. Would integrate that. Take the antiderivative, u to the 3rd, that'd be u to the 4th over 4. 1/8 times 1/4 is 1 over 32, and then instead of writing u, I'm going to plug what u is. So 4x squared plus 3 to the 4th power plus c, the constant of integration. All right, practice the other ones. Again, I'm just giving you a few helpful answers, like on 28 here. Let u be the denominator there, x squared plus 4, so du would be 2x dx, all right? I need just x dx, so I'm going to get rid of that 2 by dividing or multiplying by 1/2. So 1/2 du is x dx. I substitute in for that, so now I can write everything in terms of u. That's 1/2, 1 over u du. All right, take the integral of 1 over u, that's natural log u. Don't forget about the half, don't forget about plus c, and then I substitute what u is. So x squared plus 4, substitute that in for u. Take a look at number 30. I can just integrate, take the antiderivatives right away. The derivative of sine is cosine, so the antiderivative of cosine is positive sine. Instead of multiplying by 1/3, I would divide by 1/3 or multiply by 3. The derivative of cosine is negative sine, so the antiderivative of -3 sine is -3 cosine. Instead of multiplying by 2, I would divide by 2. There. The 2's here do not cancel, folks. That is cosine of an angle, and that angle is 2x. All right? We do not divide that by 2. I just rewrite that as 12x to the -4th, 1 power up, divide by that new power, and there we go. 32, use substitution. Anytime you have something raised to a big power, that's probably a dead giveaway. That should be u. Let u be natural log x. The derivative of natural log x is 1 over x dx, which would cancel with that. So you'd have the integral u to the 4th du. 1 power up divided by that new power. All right, plug natural log x in for u. On this next one, u is cosine x. Again, anytime you have e, whatever that power is, that's a good idea to substitute, make that u. So du is negative sine x dx. I just need sine x dx. So negative du is sine x dx. So now I have negative, the integral, eu du. Integrate that, that's just negative eu, e to the u plus c, and then plug cosine x in for u. Is a good one to know. Here on 35, folks. All right, take the antiderivatives of 3 sine 3x and -2 cosine 2x as such. simplify that a little bit, and then you're gonna, you know, plug pi over 6 in for x, and plug 0 in for x, and you can finish that one on your own. All right, folks, this one's got an easy antiderivative, and then just plug 2 in for x, negative 2 in for x. No u substitution needed there, nor do you need u substitution on 37. Folks, some of us missed this today. The antiderivative of negative sign is positive cosine, because the derivative of cosine is negative sign, so think backwards, okay? That is 4 cosine theta. Plug pi fourths in for theta and 0 in for theta, and it simplifies to be that. Number 38 is a lovely question. Let's say let u be x plus 2. So that means du is just dx. All right, so we have the integral from -1 to 2, e to the u du. And the antiderivative of e to the u is e to the u. I got to plug x plus 2 in for u, and then I plug 2 in for x, and -1 in for x. You got e to the 4th minus e to the 1st. All right, 4 over x has an antiderivative of 4 natural log x. Plug e to the 5th in for x, plug 1 in for x. Natural log 1 is 0. This is going to have a canceling effect. We know the 5 comes on down. 5 times 4 is 20. All right. 40. 40 is another good one. I know I usually say, you know, the denominator is a good hint for what you should be, but try that. Then we're kind of in a tricky situation up top. So if I let u be the numerator, 1 minus root x, then I get du is -1 over 2 root x. So I can get rid of that like -1/2 by multiplying both sides by -2. So I can get that 1 over root x dx, which I need right there, which is just going to simplify to be this, -2 on the outside, u du. Take the antiderivative, u squared over 2, so just negative u squared. Plug 1 minus root x in for u. Then you got to plug 9 in, and then 4, and take your time there. All right, that does have a little bit of arithmetic that can be tricky. All right, antiderivative of e to the x is just e to the x, and then plug natural log 4 and 0 in. E to the natural log 4 is 4, e to the 0 is 1, 4 minus 1 is 3. Okay. Moving on here, folks, 42 through 48. Cotangent, that's just cosine over sine. All right, so if you let u be the denominator there, du is simply what you see up top, cosine x dx. So 1 over u, du, the integral, the antiderivative would be natural log u. Plug sine x in for natural log, or for u. And there we go. Here, folks, if you let u be sine x, then du is cosine x dx, which is the other part. So this is the integral, lower bound 0, upper bound pi fourths of u du. That would be u squared over 2, the antiderivative. Plug sine x in for u. So you have 1/2 sine x squared evaluated at pi fourths, and then at 0. Well, sine of 0 is just 0, so just plug in sine of pi fourths, which is root 2 over 2, square that, multiply it by 1/2. I think you get 1/4, but definitely check that. This is a very classic u substitution problem. Let u be that exponent, then du would be -3x squared dx, but I only need x squared dx, so I got to get rid of that -3 by multiplying both sides by -1/3. All right, so then u substitution gets me right there. When I take the antiderivative of e to the u, I'm just going to get e to the u again, so I might as well plug -x to the 3rd in for u. And I think we did this one in class, so that result is going to follow as well. Okay, get a little lazy on these because I don't have much room. U is 3x minus 2. Technically, you could distribute that out if you wanted to. So du is just going to be 3 dx. So if I just need dx there, 1/3 du is dx. U substitution gives me this. Integrate, or take the antiderivative, u to the 3rd, that is 1/4. U to the 4th, 1/3 times a 4th is a 12th. Then I'm going to plug 3x minus 2 in for u, evaluated at 0 and -2, and we can get that. All right, next one I want to do with you is 48. Let u be natural log x. So du is 1 over x dx. This is going to give you 1 over u, du. Remember we did this one. This is natural log of natural log. All right, which turns out to be that. Natural log 4. Relatively okay answer. All right, then a few more here, folks. We kind of did this one earlier. This is just u substitution. Cotangent is cosine over sine. All right, you're going to get natural log u, so this is going to be natural log of sine x. Then plug in pi halves, plug in pi 6. I think it's going to be, first off, sine of pi halves is 1, right? So that's just going to be 0. So minus natural log of 1/2, right? Again, you should probably check that. I think we did that one in class, though. Let's let u be sine of theta, all right? So du is going to be cosine theta d theta. So this is u to the third, and a derivative of that is u to the fourth over 4. So this is going to be sine theta to the fourth over 4, evaluated at pi halves, so it's going to be 0. And then pi fourths. We did that one in class as well. Root 2 over 2 raised to the fourth divided by 4 is going to be your answer, whatever that simplifies to be. In this example, let's let u be cosine x. So du is negative sine x dx. That means this sine x dx that we need to have something to substitute in for. That's just negative du. U substitution gives me this. Take the antiderivative, u to the third divided by 3. Don't forget about that negative 1 though. Plug cosine x in right there. So cosine of pi halves is 0, and then cosine of 0 is 1. If you subtract that negative, is it 1/3? You should try that. It's looking like maybe 1/3. All right, 54 here, just take the antiderivative. So you got to go backwards here, not taking the derivative of sine x. You're thinking what derivative gives you, the derivative of what gives you sine? Well, the derivative of cosine is negative sine. So the antiderivative of a positive sine would be negative cosine 3 theta. And instead of, if I was, doing a derivative, I'd have to then multiply by 3, because that's what's attached to theta there. So then I would divide by 3. So it's going to be negative 1/3 cosine of 3 theta. Not cosine of a single theta, but 3 theta. And then plug pi thirds in. 3 times pi thirds is pi. 0 times 3 is still 0. And this turns out to be 2/3, I believe. All right, this video is almost over here. We did 55 together. Folks, you got to first figure out when these graphs intersect. So set x to the third equal to 3x squared. And you get 0 and 3s when they intersect. So we're going to have some bounds of 0 to 3. And I want to figure out which equation, so I don't have to graph this, which graph is always going to be on top and which one's going to be on the bottom. So which one's y top, which one's y bottom. Plug in a number that's between 0 and 3. So in this case, 2 would be a good number. Plug 2 in there, plug 2 in there. 8 and 12. 12 is bigger, so that's y top. That's why we're going to have this minus this. All right, we're going to integrate that. We get 27 again. We're evaluating that from 0 to 3. All right, we get 27 over 4. Folks, we did 57 in class as well. Again, we set those two equations equal to each other. Square both sides. We get 0 and 1. So we're going to integrate, from 0 to 1 of something. In between 0 and 1 is a half, so plug a half in. So y top is actually going to be root x, as we got there. Integrate that. And I think our final answer is 5 over 12. All right, folks, got to get this video done in under 15 minutes, so it can just be one video. Lastly, what could be on tomorrow is find the derivative of each function. All right, if it's simply a to x, then you can just plug x in, and boom, that would be the derivative of that integral. Here it's some a, so 2 to x to the third, so I would do the same thing. I'd plug x to the third in for t, but then I have to take the derivative of x to the third, because it's not just a single x. All right, and then lastly on 68, so you could have 2 of these tomorrow. On 68, it is not a to x, it's some x to a, so I have to flip it, so that'd be the opposite answer. That's why there's a negative on the outside. I'm going to plug x squared in for t, but I also have to take the derivative of x squared because it's not just a single x. And that would be my answer. All right, folks, exam number 3, part 2 tomorrow, folks. Practice these questions big time. This is Yak Math Videos signing out.